Welcome to the 2022 Bots on Wheels Community Robotics FRC Team 4290 Recruitment Presentation. My name is Anish, the business captain and a rising junior on the team.
I am Rishi, the build captain and a rising senior in the team. So in terms of what we want to cover in this presentation today, we want to give some information about who we are at Bots on Wheels, what we do, how we do what we do, our student life team structure, and how we go through our engineering process and all the robots that we make and all the impact that we've had in our community. And just to give you guys an idea about everything we do at Bots on Wheels.
So we are a community-based robotics team. We competed with 21 students in the past season, representing 8 different schools, led by 10 mentors. 45% of us are traditionally underrepresented in STEM field, and 55% of us fall under BIPOC.
So we wanted to create a slide that gives us a good idea about everything that we do. And I think this slide does a good job of encapsulating that in terms of the 3 C's: create, compete, and community. In terms of create, so every January with the first robotics competition, we get a design challenge. And this design challenge usually takes the form of some sort of gamified sport. And our challenge, we take the game manual and we read through all the rules, we brainstorm, and then we start building a robot. And all this happens from scratch. So we get the rules and then we start brainstorming and building a robot that would essentially be the most ideal robot to play that game with our given resources and our given time frame. And then after we put in that hard work over the course of the few months, we then go to compete. That's the second C. And in terms of compete, we compete in an FRC competitions. And so we usually have around 3 competitions, 4 based on how we do in them. And these competitions are truly some of the more fulfilling parts of our season at Bots on Wheels and First Robotics, because you get to meet such amazing, brilliant people when you go to competition. You have the opportunity to win multiple awards and get a lot of recognition, but also you get to see so many other designs and so many other amazing teams that have also done some brilliant work, and you get to interact with them. And the final part, the why of what we do, everything we do, is community. It's to impact students and get people involved in STEM and to spread those values of FIRST and STEM through multiple avenues.
So I want to also talk about our mission statement to give you, a few words to just visualize what we do. So we teach others about STEM and FIRST, and that's been our mission statement since 2012, and we've been working towards fulfilling that every year.
So we've talked a little about Bots on Wheels, and we've said FIRST and First Robotics quite a bit over here. But we wanted to give you guys an idea about what exactly FIRST is, and I think this video from FIRST does a good job of doing that.
FIRST was founded in 1989 by Dean Kamen. As an inventor, he realizes that the way to have the biggest impact is to create a whole generation of new inventors. Through hands-on, engaging robotics challenges, FIRST ignites passion in STEM for kids ages 6 through 18. There's 4 worldwide programs.
Once you get the challenge, you figure out your game plan.
You make a robot and you code on it.
Throughout each of our programs, teams embrace FIRST core values.
Discovery. Innovation.
Impact.
Inclusion.
Teamwork.
Fun.
At face value, FIRST is a robot competition, but at the end of the day, it's so much more than that.
We learn a lot about leadership, how to communicate with others, problem solving,
working together, helping other teams.
Our mentors teach us not just about STEM, but about life.
I think it's incredibly important for youth to see careers in science and engineering as a possibility for them.
FIRST actually taught me that I'm capable of doing anything that I set my mind to.
There's nothing better than seeing your robot on the field playing for the first time. They're all there like, is it gonna work? Is it gonna work? And then when it works, it's the best feeling ever.
As a participant in the FIRST program in high school, you get access to $80 million worth of scholarships.
There are scholarships for colleges, universities, as well as technical programs.
FIRST really develops a pipeline where there's jobs, there's careers, there's opportunities for every one of these kids based on the skills and the experiences they develop in these programs.
In FIRST, every student can go pro. It's a really cool way to step into your future.
I am first.
Yo soy first.
I am first.
I am first.
All right, so I think we got a few stills of what competition looks like at FRC, but to touch a little bit more on that. So FRC competition events is where we take all of our hard work from the last 3 or 4 months of brainstorming and building a robot from scratch, and we go to showcase it at a competition event, which usually takes place at some sort of UNC system university. And then these are places where we all travel as team members and students. And the good thing is at this point, we're probably already acquainted with our teammates and we have a good relation with them. And that what that allows us is we go as friends and we stay there as friends. And it just makes it a really good experience where we meet other teams, we compete, and there's a sense of cooperation, which is a word that first coins in the sense that it's competition and also cooperation. And so other teams are really helpful, helping you fix a lot of this stuff because there's a lot of problem solving that also goes on during competition. And you learn a lot of those kind of in the moment, how to face problems, how to fix them, and how to work with them. And that's why they're really good learning experience at all times. So now that we've talked a little bit about first, we want to get back to Bots on Wheels in specific. And so here's a little bit about our team structure, because one of the reasons why I joined Bots on Wheels and one of the reasons why multiple people in our team will also kind of say that they also joined our team was because of the fact that we're a relatively tightly knit team. So we usually have around 20 to 25 students. And what that allows us to do is it allows every student the opportunity to make a lot of change and impact the way the team does things. And that opportunity to make change and to improve and to get involved as much as you want to also comes with a responsibility. And that usually takes the form of leadership. And so there's a lot of opportunity for leadership and there's a lot of opportunity to make an impact, which is what we think makes our team unique. And so to give you guys an idea of the structure, we usually have a team coordinator or a team captain who's responsible for facilitating communication between different sub-teams and just overseeing the functioning of the student side of the team. And these different sub-teams include the build team, the programming team, and the business sub-team. All three of these sub-teams also have their own captains, the business captain, the build captain, and the programming captain. And they're responsible for all the functioning and all the students and all the work that's been going on in those specific sub-teams. The communication between all three of them becomes especially important during build season because there's several amounts of work going on in each of these sub-teams. And so other leadership positions that we also offer in our team include a safety captain, an electrical captain, which is part of the build team, and an outreach captain, which becomes part of the business team, and also a strategy captain.
So we've talked a bit about our team and what we do. We want to actually take you on a journey through our engineering design process now, so you can see how we design a part or a subsystem from start to finish and how Bots on Wheels specifically will do it. So we're going to be taking a look at our indexer subsystem. And in our previous robot, our 2022 robot, it moved the game piece from our intake mechanism to our shooting mechanism. So right here, this is something I actually worked on designing, and that was as a business captain. So again, it goes to show how tightly knit we are. I was able to work with the business team and engineering team at the same time. But as you can see here, we just have a hand-drawn sketch right now, and every great idea begins with one of those. Then after that, we work on developing it through a computer-aided design program. We prefer to use SolidWorks, and we train our students in that. So we make a basic CAD sketch, and as you can see, some really basic shapes right now and some dimensions we can choose to work with and play around with.
So yeah, after we do those basic sketches in SolidWorks, we then go forward and do all the dimensioning and all the extrusion that we need and all the basic stuff that we need in SolidWorks to create the full CAD model. And this full CAD model is a really good thing to do because not only does it prove to be a really important skill that students develop over the course of the season, because having CAD experience, computer-aided design, and working with these softwares can become a really good skill to have, especially going to industry and engineering. But also from a robotics perspective, it allows us to do so much because it essentially gives us an idea about the pros and cons of our design once we model it. And that's something we really doubled down on this past season, and we intend to continue with that in the coming seasons, because these designs give us a good idea of, okay, so here's an idea that we had. Let's put it on paper, and then let's convert it into a model that we can see and rotate and see how they work. And then it also allows us a good pathway to get into the next phase of the engineering design process, which is the prototyping phase. So yeah, the next phase always turns out to be the prototype. And so we have multiple avenues and multiple ways we make prototypes in our team. So we have materials like wood, foam boards, and polycarbonate sheets that we use to make these prototypes. And the aim with them is usually to ensure that all the criteria and constraints that we've taken from the game manual and everything that we want from our robot is being fulfilled by a specific subsystem. And so one of the major things that we do with these things are we'll take our game pieces. So whatever game piece there is for that game that year, this year was like an oversized tennis ball, and we'll take them and we'll see how they work with that specific subsystem. And so it gives us a good idea about how the physical things actually work with each other mechanically and what we need to work on. So for example, on this one, another thing we test out with our prototypes is how a specific subsystem is working with another subsystem that we developed. And so in this one, we had the indexer, but as you can see, we're testing it along with the intake mechanism, which is the mechanism that takes the balls in from the ground. And we realized that after we put them together in the prototype, that the intake needs a little bit more space to maneuver once it goes back and forth while taking balls. And so that was a modification we had to keep in mind. And so we took that, we recatted it, we made some changes, and then that allowed us to move to the next stage, which was the final iteration.
So yeah, as Rishi mentioned, the final iteration is the last step of the engineering design process. And as you can see, we have a picture of our finished indexer on the side, and you can see that cutouts have been made on the side walls of the indexer, to incorporate the intake mechanisms folding. After this, we still do ensure functionality by testing it individually, making sure that it does work as expected. And you can also see that, the motors have been mounted at this point. And then we choose to mount it on the robot. And then we have to make sure it fits in with the integrated component system. This basically means that the components on our robot, all the subsystems, work in conjunction to ensure an optimized design. So for example, if we are intaking a ball, the lower stage of our indexer will also be spinning and to intake it up to there, to the top part of our indexer. We've talked about, the engineering side of our team. Let's now talk about student life. And by that, we mean how BOW pick crew students, as we're called, do outside of meetings. We form lasting bonds with one another. We're all friends with each other, and that friendship really becomes apparent when we go to competitions. Outside of meetings, we were playing sports or, esports, just hanging out and having fun together. And also in regards to our accomplishments, we've had quite a few over the past 3 seasons. We recently won the District Chairman's Award at a district event, which is the most prestigious award at a district event, and it's in thanks to our efforts on outreach. We also won the Autonomous Award, and we're an event finalist. We also boast a 100% high school graduation rate, and students on our team have went to many prestigious universities such as Caltech, NC State, etc. And we also have a 100% acceptance rate to the NCSSM residential program. So basically everyone who's applied from our team for the NCSSM residential program has been accepted. And we've also talked about the community part of the 3 C's earlier in the presentation, and this leads to opportunities. So as a BOW member, you're able to lead and participate in many community impact projects, including summer STEM camps, which you can be a lead instructor for, just instruct Title I students and middle school students. We do a lot of impact in terms of Title I students, and I will go into more detail in just a second. We spread the message of STEM and FIRST worldwide through, social media, worldwide live streams, etc. We do robot demonstrations across local community centers, and we also get to work with organizations, big and small, such as Collins Aerospace and Best Buy. So in regards to the Title I students, I would like to show you our Connected Together initiative. This was our most successful initiative, and basically it was created by us and Best Buy gave us the fuel. It was an invitation-only grant provided by Best Buy, and it gave us over $18,000. We used this to provide 72 Chromebooks to Title I students and give STEM classes to these students. And a number to focus on, I guess, is from the past 3 years, we've impacted over 341,000 people. And we're excited to exponentially grow this amount. We also would like to show you our impact video, which is basically our chairman's video, which was presented after we won the chairman's award in our last district event.
Underdogs. A competitor thought to have little chance of winning a fight or contest. We don't like that definition. Underdogs surprise you. Underdogs fight the hardest. Underdogs persist no matter the challenge. We know what it's like to face hard times, to be the so-called underdog. We've made mistakes. We've had our failures. We've even questioned our team's survival. But that has only pushed us to work harder, do better, learn, and grow. When students come together, they persevere. They change the world.
We support the underdogs of our community, the underrepresented. We helped create a virtual STEM camp for Title I middle schoolers. We had the honor of teaching them about STEM and engineering. We watched them learn, overcome challenges, and use their creativity to construct new and imaginative designs.
We believe that a single moment can impact a life forever. Our flagship Connected Together initiative provided Title I students with Chromebooks and STEM classes. With this, they were now free to use their imagination to take on the world. This moment opened their doors to success.
We see how hard these students fight for their passion to make change. They're redefining what it means to be an underdog. But we don't stop there. Outreach after outreach, we support the underrepresented. From local community centers to worldwide live streams, our devotion towards inspiring STEM and FIRST and others has never changed.
We have even taken this passion to mentor and assist other FIRST teams. We are Bots on Wheels FRC Team 4290, and this is how we roll.
Now that we've talked a little bit about the team, we want to talk a little bit about how you can actually join and some of the specifics, financials and stuff like that. So there is a $225 joining fees, which is the fees that you pay for joining for the first year. And that includes the t-shirt and camo pants, some really good gear that we wear to competition. So basically our Bots on Wheels merchandise almost. And then every year there's a $500 fundraising goal that students are supposed to fundraise for the team. And so the good thing with this goal is the fact that our team provides so many opportunities to fulfill that $500 fundraising goal, because this truly is fundraising. So for example, one of the things Anish mentioned was virtual STEM camps for Title I students, of teaching students stuff like basic programming and basic Tinkercad skills. And that's one of the opportunities to which students can not only participate in such outreach, but also there's money that comes in through those camps that goes towards their specific and individual fundraising goals. So that's one of the major ways that a lot of our students do fundraising. Another way that we've done over the past few seasons, and it's become really successful, is we've partnered up and we've worked concession stands at the Charlotte Knights Stadium and the Panther Stadium. And again, the work we do at the concession stands, some of the returns, and those returns go to this individual students' fundraising goals. So based on how much they work and stuff like that. And our team also does facilitate need-based scholarships for all of these financials. So I know a lot of questions are going to be around the fact that what does the timeline look like for joining an extracurricular like robotics? It's also one of the things that we've already encountered is students asking, what's the time commitment like? And so I'm going to give you guys a general overview about what a whole year looks like inside of robotics, and then Anisha is going to get specific and into the weeds about what a specific schedule looks like during build season. So May through December, the months from May through December, which is where we're at right now, is what we call off season. So it's the time period during which we're not actively building a robot to prepare for season-based competition. It's the time where we're doing a lot of other stuff that we need to do just to prepare for season, or just to do stuff that we don't have time to do during season. And so that involves training. So for example, right now we're executing a whole training program in which we teach students SolidWorks, which is our CAD software. We teach students stuff about programming in Java, and we also do presentations and hands-on work with a lot of other tools and machinery, and a lot of build stuff and a lot of other business soft skill stuff as well. And so we'll do training with that during the off season. Another one of the major things that we do during off season is community impact stuff. So outreaches, STEM camps and stuff like that. We do a lot of that stuff during the off season because that's when we have the time and the resources to do that stuff. And so during the off season, time commitment amounts to approximately 2 to 8 hours a week. And that is sort of a wide range, because we realize when we understand that a lot of students have stuff going on, because this not only does it fall during the summer, it also has fall because we understand that students have other commitments. And so 2 to 8 hours approximate to around 2 meetings a week. And it usually falls one of them on a weekend and one of them on a weekday, like a Tuesday evening or something like that. And so yeah, that's what the time commitment looks like during the off season. And then we move from January through April, which is essentially the brunt of the season. That's the core, and that's what we call build and competition season. So January, as we said, we get the design challenge, and then through April, we're actively brainstorming and building that robot. And we have really limited time frame to do so. And so that's why the time commitment during this time period is heavy. Students are expected to actively be involved in whatever aspect of the team they're involved in, or whatever aspect they find interesting or want to learn more about. And approximately 15 hours a week is expected, and Anish will go into a little bit more about the specifics and the flexibility that we have with the same.
So yeah, I'm going to show you a schedule we used in the past season. We ran this from January to the middle of March before competition started. And basically we had, 3 days on the week, 3 weekdays where we'd have evening meetings that lasted 3 hours each. And then on Saturday we had a morning to, late afternoon type meeting. And on Sunday and Wednesday and Friday, there would be meetings depending on your focus groups, or if they were needed, depending on the progress on the robot and, other rewards. So definitely there is flexibility. We do expect around 15 hours a week, but as you can see, there is opportunity to, miss a weekday and still make up for those 15 hours. The other question you may have is, do I need to come to the zone, which is our workspace, every time there is a meeting? And the answer to that is, it depends on your focus groups. For example, if you're on, the business chairman's side of things, you may be meeting virtually more than in person, because some of the work can just be done virtually with a group, with your team. And programming, you can screen share in the Discord and also work together. The most important thing is we do love working together, and we do that all the time, in every meeting, virtual or in person. But there is definitely flexibility here.
That's essentially all we have for the information recruitment presentation. Thank you for listening to us out. And yeah, thank you.
Thank you.